Hey everyone, welcome back. This is Dr. Lewis once again. So, at the end of this metabolism series, my goal is to help you think scientifically about obesity and metabolic health, to truly understand why the body stores fat, why it burns fat, and why losing weight is often more complicated than people realize. We first need to understand the science that governs metabolism itself. And that science begins with chemistry. In the last video, we defined metabolism as the sum of all the chemical reactions occurring inside your body. These reactions allow you to think, breathe, move, maintain body temperature, and ultimately stay alive. But that raises an important question. What exactly is a chemical reaction? To answer that question, we need to start with the basic building blocks of matter. One of the things that distinguishes our environment from the empty vacuum of space is the presence of matter. Matter is anything that has mass and occupies space. Everything around you is matter. The air you breathe, the water you drink, your body. The basic unit of matter is called an atom. Everything in the universe is ultimately made from atoms. When atoms of the same type are grouped together, we call them elements. Oxygen is an element. Hydrogen is an element. Carbon is an element. Iron is an element. Gold is an element. In total, we currently know of 118 elements. The periodic table is simply a catalog of all the elements known to science. We typically use one or two letters to represent each element. Importantly, every element has its own unique properties. Iron behaves differently from oxygen. Oxygen behaves differently from carbon. Gold behaves differently from calcium. But things become even more interesting when different atoms bond together. When different atoms form chemical bonds with one another, they create molecules. And molecules often have completely different properties from the atoms that form them. For example, hydrogen gas and oxygen gas have very different properties. Yet when hydrogen and oxygen combine in the proper ratio, they form water. Water behaves completely differently from either hydrogen gas or oxygen gas. This is the power of chemistry. A chemical reaction is simply the process by which atoms are rearranged. Existing chemical bonds are broken, new bonds are formed, and new molecules are created in that way. In essence, molecules are converted into different molecules through chemical reactions. We call the starting substances of the chemical reaction reactants. We call the substances that are formed products. Hydrogen and oxygen are the reactants. Water is the product. Here is a relatable, real-world example. Historically, soap was made by combining animal fat with a highly caustic substance called lye, also known as sodium hydroxide. Neither fat or lye has the cleaning properties of soap. But when they react chemically, they create an entirely new substance with completely different characteristics. That substance is called soap. This is chemistry in action. And here's why all of this matters for people struggling with obesity. Life itself depends on an enormous network of chemical reactions. The storage of body fat is a series of chemical reactions. The burning of body fat is also a series of chemical reactions. But this raises another important question. Why do chemical reactions happen in the first place? Why don't atoms simply remain unchanged forever? Consider iron. The rusting of iron is a chemical reaction. Oxygen reacts with iron to produce iron oxide, which we call rust. But why does iron rust? And why doesn't rust spontaneously convert back into pure iron? Another example is gasoline. When gasoline burns, oxygen reacts with gasoline to produce carbon dioxide, water, and energy. But why don't carbon dioxide and water naturally reassemble themselves into gasoline? Why does the reaction seem to move into one direction but not the other? And perhaps most importantly for this series, if the storage of body fat and the burning of body fat are both chemical reactions, why does the body favor one process under some conditions and the opposite process under others? Those questions take us into one of the most important concepts of science, thermodynamics. In the next video, we are going to explore why some chemical reactions naturally proceed, why others do not, and how the laws of thermodynamics help explain the chemistry of life itself. I'll see you here.